A quiet, dark night over the Pacific Ocean always causes a strange feeling. It's as if the endless void under the wing takes in everything: light, sound, and thoughts. Everything dissolves into this impenetrable depth from which neither the dense double-glazed windows of the portholes nor the multi-ton body of the aircraft will protect. February 24th, 1989. The clock on the dashboard shows well after midnight. At an altitude where the air becomes so thin that any breathing seems forced, a huge Boeing 747 United Airlines is moving over the ocean. There are more than 350 people on board. Someone is sleeping. Someone is closing their eyes in a half-doze. Someone is just beginning to get comfortable, trying to survive the night flight between Honolulu and Auckland. A regular flight, an ordinary night. The smooth hum of the engines going in unison with the calm pulse of the crew. Nothing foreshadows anxiety. And yet deep inside the machine, in its aging metal body, equipped with devices that have long since given way to digital technology, there is a vulnerability. No one on board knows about this. No one should know. The plane is in good working order, the crew is experienced, and the sky over the ocean, despite the thunderstorms on the course, seems quite tolerable. There are calm, collected people in the cabin. Captain David Cronin stares intently at the instruments. This is one of his final flights before retirement. Almost 30, 5 years of flying, tens of thousands of hours in the sky. All this honed his movements to automatism. He knows how an airplane breathes, how it reacts to the slightest loads, and how it behaves in any case. Next to him is his longtime partner, First Officer Gregory Slater. 2 decades together in a cockpit is like 2 hands of the same organism, where one is just starting a thought, the other is already performing an action. Their interaction is almost telepathic, calm, confident. They experienced thunderstorms, equipment failures, turbulence, and unexpected dispatcher decisions. But tonight seems ordinary, even a little lulling. Behind them is flight engineer Randall Thomas. His workplace resembles the heart of a ship. Hundreds of indicators, toggle switches, light bulbs, and data streams. He monitors the state of the systems, detects the slightest deviations, and reacts instantly if something goes wrong. But it's okay now. The engines are stable. The cabin pressure is even. The electrical circuits are without features. Honolulu stays behind. The lights of the city fade into the darkness. The plane heads southwest, rising higher and higher. The captain approves the altitude, checks the speed, slightly adjusts the direction, bypassing the lightning formations. Nothing critical, just routine. Passengers are buckled up. The captain decided to leave the "fasten seatbelts" sign on, knowing that nighttime thunderstorms sometimes bring surprises. This small decision will save dozens of lives, but right now it seems like a minor touch. Dim lights create a cozy atmosphere in the cabin. People are trying to get comfortable, recline their chairs, and cover themselves with a blanket. On the starboard side, closer to the middle of the cabin, several people are looking out the windows. There is only continuous blackness. No shores, no reflection of the moon, just a silent ocean. It's only been 17 minutes since takeoff. The plane reached an altitude of about 22,000 feet, about 7 kilometers. The hum of the engines is steady. A slight vibration of the wings is a normal phenomenon for such a giant. The flight engineer reports on the standard parameters. The first officer checks the route chart. The captain estimates the distance to the turbulence zone. Everything is going according to plan. And at that moment, the silence turns into a harbinger of disaster. At first, there was a barely perceptible sound, a blunt, short kick somewhere to the right. Not like the impact of an air pit. It doesn't sound like any regular noise. So unusual that the crew instantly takes their eyes off the instruments. But only a fraction of a second passes, and everything changes. A thunderous explosion pierces the aircraft body. It is not just audible, it is felt physically, with the whole body, as if a blow of immense force pierces the fuselage. It is followed by instant and violent depressurization. The air escapes from the cabin to the outside, turning into a lightning, fast stream that there is nothing to stop. There is chaos inside. Screams mingle with the sound of tearing metal. A hole forms in the right side of the cabin, so huge that the black ocean is visible through it. The pressure drops instantly. Oxygen masks fly out of the ceiling panels, but they are useless. The supply system is damaged. In the cockpit, the captain tries to shout over the hum, checking the mask. She doesn't work. Neither he, nor the co-pilot, nor the flight engineer. The next few minutes will decide everything. If they don't manage to descend, the sky over the ocean will become their last space. The plane, deprived of part of the side, begins to vibrate. The devices are flashing, alarms are triggered. And ahead, there is only darkness, thunderstorms, and hundreds of kilometers to the nearest lane. So begins a story in which every breath, every second, and every decision will cost human lives. At first, it seems that the plane is just shaking. But after a few seconds, it becomes clear. This vibration is not related to the air. It's ragged and chaotic, as if the giant's entire structure is trying to resist a force it wasn't prepared for. The cabin pressure drops rapidly, so rapidly that the crew's eyes fill with tears from the pain in their ears. The sound becomes low, booming, as if someone has turned on a huge fan inside his head, mixing the air with his own thoughts. Captain Cronin understands instantly. This is a depressurization, and it's not just some kind of air leak. It's a catastrophic collapse of the hull. He pulls the steering wheel forward, putting the plane into an emergency descent. This is the only chance to get away from a height as quickly as possible, where the human body cannot exist without oxygen. The height is still too high. Passengers are already disoriented in the cabin. Those who did not have time to put on masks begin to feel dizzy, squeezing of temples, weakness. Some people see an approaching tunnel in their eyes. This is how hypoxia begins. The brain stops receiving oxygen and simply turns off. But the crew can't use masks. They keep them on their face, but there's an emptiness inside. No air is coming in. The damage affected not only the fuselage, but also the oxygen supply lines to the cabin. Are you getting something? No, nothing. Me too. The only sound in the cabin is heavy breathing and the alarm bell blaring, and then a new trouble, quickly, almost casually reported by the dry numbers of the devices. Engine number 3 is vibrating. Strongly. The flight engineer bends over to the panel, peers at the readings, and his heart instantly sinks. The parameters on the third engine are beyond the norm. It gives out the strongest vibrations. The thrust drops. This is not the result of wear and tear. This is a consequence of the impact that the plane received. The flow of debris thrown out, blown air, structural shifts, all this could hit the engine. The third engine, we have problems. Turn it off. It's not a quick decision. It's instinctive, worked out over the years. The crew knows that in such a situation, the affected engine may catch fire or even fly apart, damaging the wing. Therefore, it is jammed, leaving the aircraft on 3 engines. But it is at this moment that Cronin feels for the first time how difficult this night will become. 300 tons of weight. Only 3 engines are running. The black emptiness of the ocean under the wings, the destroyed fuselage and vulnerable structure. Total darkness and thunderstorms behind and ahead. And this is just the beginning. The plane goes into a steep descent. Cronin simultaneously presses the steering wheel and keeps the plane from speeding up so as not to smash it against its own aerodynamics. This is a balancing act between 2 deadly threats. Too fast, the plane may fall apart. Too slow, the crew will lose consciousness. In the cabin, meanwhile, there is something between chaos and stupor. The people on the right side, closer to the destroyed section, are sitting motionless, as if in a deep trance. They look into a slit hole, where instead of a wall, there is an open abyss. Torn metal, pieces of cladding, and shreds of interior trim fly by. They hear the deafening howl of the wind, the roar of the remaining engines, the echoes of what is happening in the cockpit, although they do not distinguish anything. Several passengers are still semi-conscious. Some are in shock. Those who are further away from the destruction do not understand what exactly happened. They only see the masks. They only hear the screams of the flight attendants. They feel the plane falling down. One of the flight attendants, who was too close to the rupture, was half thrown out. His colleagues are holding him by the straps. He is wounded and in pain, but he is alive, creating a miracle in the midst of chaos. Meanwhile, the situation in the cabin is getting worse. The captain is trying to keep the plane at an acceptable speed, but now a new problem arises. They are being pulled to the right. The car seems to be resisting control, unable to keep a straight course. Cronin presses down on the left rudder pedal, practically doing his best physically to keep the plane from turning around. And at that moment, the instruments show one more thing. Engine number 4 is not in order. There are 2 working cars on the right wing. One is already turned off. The second one starts to fail. The decline is going too fast. The weight is too much. Honolulu is far away, like the only island of salvation. But far away. Too far away. We lose traction on the 4th. If he comes out, we may not come back. We don't have a choice. We continue to decline. At this altitude, critical decisions are made in less than a second. Everything depends on them. The fate of the people in the cabin, the fate of the crew, the fate of the plane, trembling under the gusts of the night ocean. They don't know yet that they're going to see the fire soon, that they will soon be forced to run on 2 engines, that the weight of the plane would turn into their main enemy. But for now, the main thing is to reach 10,000 feet. Don't lose consciousness. Do not destroy the plane. Don't lose control. The chaos is over, chaos is ahead, and there is no guarantee that at least something will keep this plane in the sky. ChatGPT said, "When it seems that the situation has reached its limit, reality adds another round of tension. A fire breaks out on the right wing, where engine number 4 was fighting for its life a second ago. At first, it looks like a reflection, a dim, wavering light somewhere behind the wing panel. But after a moment, it turns into a flaming stream, elongated fiery tongues rushing back in the direction of the airflow. Passengers sitting at the right windows freeze in a stupor. They see that trail of fire all too clearly. Fire bursts from the engine, trailing along the wing in a plume, coloring the dark night in alarming orange-red hues. For them, it looks like the final moment, as if the plane is about to turn into a molten lump of metal and disappear into the black water under the wing. In the cockpit, everything happens faster than fear has time to form. The fourth one is on fire. Put it out. Extinguish it immediately. I'm turning off the fuel supply. The flight engineer's hands move along the panel, as if mechanically, carefully, even too fast for an ordinary person. Fuel supply cutoff. Activation of the fire protection system. Cutting off the line. And silence. Silence in the sense of lack of traction. Engine number 4 is no longer involved in flight. The burning fire goes out, and there comes an almost unbearable moment of realization. Now the 747 is flying on 2 engines. Both are on the left wing. The entire right side of the aircraft's carrier system seemed to have been torn out. A hole in the fuselage, 2 dead engines, impaired aerodynamics, unpredictable load on the structure. The huge weight of fuel in the tanks is still too much for such a flight mode. The plane is now trying to turn right, like a giant feather being blown by a strong crosswind. Cronin presses on the left pedal of the steering wheel so that an audible crunch goes through the cabin. It's not the metal creaking. It's the effort of a man who is literally trying to keep the car from turning. The steering wheel is almost completely deflected, and this creates even more resistance, slows down the plane even more. It starts to decrease faster. We're losing altitude. I'm holding on as long as I can. We need to get rid of the weight. Immediately. The flight engineer reaches for the emergency fuel discharge system. This is not just a decision. It is a recognition that there will be no miracles without reducing the mass. From the outside, it seems that dumping fuel is a trivial technical procedure. But here, it's a struggle for every meter of height. The ocean beneath the wings is getting closer. It is impossible to allow a decrease below the limits at which the pilots will be able to maintain speed. The flow of fuel begins to leave into the night, spraying thin jets behind the aircraft. We're dropping 5,000 pounds a minute. It may not be enough. The speed is dropping. The vertical velocity is increasing. The engines roar in takeoff mode. In this mode, they can run for minutes, not hours. It's a risk, but there's no choice. On the left, on the 2 engines that remain alive, the sound becomes almost deafening. They are exerting all their power, trying to pull a 300-ton giant, wounded, with a huge hole on the side. But you can't fool physics. With such an asymmetry of thrust, the 747 still tends to get out of control. Slater, the first officer, glances at the course marker. We're going off course. I know. I need to fix it. I got him. Cronin is almost screaming, but not from fear, but from the strain. At such moments, the commander ceases to be an experienced pilot. He becomes an athlete, fighting with dozens of tons of force on every move. Meanwhile, the dispatcher is trying to clear things up. He sees on the radar that the plane is not keeping altitude. He's drifting. He turns with difficulty. But communication remains stable, and the crew transmits short, concise messages. We've dropped 2 engines on the right. We're losing altitude. We're dumping fuel. Let's try to stay on the level. Each phrase is not a complaint, but a cold report. Against the background of this struggle, the engineer comes up with the idea. He must see what is happening in the cabin. He doesn't know the extent of the destruction. There is no direct view of the right side of the fuselage in the cockpit. He gets up, unbuckles his seatbelt. His movements are heavy, as if he is overcoming the attraction of two worlds, and heads for the stairs leading to the lower deck. Below is the cargo area, the passage to the technical part. He should look with his eyes, not by instruments. Every step he takes is a step into the unknown. He descends, holding on to the handrails, while the plane vibrates like a huge living entity. And there, he freezes. There's more than just damage in front of him. He sees a gaping hole the size of a truck. Its edges are broken, the metal is twisted outwards. Beyond it is night, in which not even the ocean is visible, only the wind and the roar of the remaining engines. Some chairs were torn out along with people. There are none. They were gone. And this image will stay with him for the rest of his life. He returns upstairs, almost running. "Captain, there's a huge hole. How big is it?" "I don't know, but half of the starboard side is missing." "Passengers?" "Some went outside." "So it's not just a rupture. It looks like an explosion." "Yes, it looks like an explosion." Now the crew understands everything. This is not a rejection. This is a structural failure. They're flying in the sky on a plane that's not supposed to be in the air. And there's only one thing ahead: an attempt to stabilize the situation enough to reach the runway. Even if you have to keep the plane in a narrow frame of speed, altitude, and guidance, as if balancing on the edge of a knife. The cabin seems to be narrowing. The space in which the three men used to work quietly now seems cramped, as if the walls of the plane are creeping closer. Not from fear, but from concentration. From the responsibility that presses from the inside. From the fact that any mistake, even a microscopic one, can no longer be forgiven by the construction, the sky, or time, which is carried down with the loss of height. The flight engineer sinks heavily into his seat. He can still hear the roar of the wind in his ears, feels the cold, almost tangible vacuum that's stretched through the hole in the side, so large that there is no longer any structure, shape, or geometry of the plane. Only a ragged edge and a world beyond human logic. But there's no time to digest what I've seen right now. He goes straight to the instruments, taking a cursory look at the residual parameters of the systems. The hydraulics are holding up. The electrics are intermittent, but they work. Cabin pressure is low, of course, but at 10,000 feet, it's enough for life. The plane is falling down too fast, and the co-pilot is saying out loud what is already clear. "We are not maintaining altitude." Cronin nods briefly. This phrase could be left without words. It is already written by trembling in the hands, tense muscles on the legs, the growl of engines that operate in a mode that is contraindicated for them according to all operating rules. "How much are we dropping?" the captain asks, without taking his eyes off the aircraft horizon. "About 5,000 pounds a minute," Thomas says. "We need more. But it's impossible anymore. The system is already working at its maximum." The car dumps fuel in a smooth arc that dissolves into the night. Every gallon that goes overboard makes the plane a little lighter. And every gallon is a chance. But it's a very slow chance. Meanwhile, the co-pilot notices something that has been worrying for a long time. The speed is fluctuating. "We are close to 240. You can't go any lower." These words are not a recommendation. It's a verdict. If the speed drops below 240 knots, the aircraft will become more uncontrollable. But it is also impossible to exceed 250, because the damaged structure may simply not withstand the load. Cronin squeezes the steering wheel. At this moment, he is holding the car in a narrow corridor. 10 knots. Only 10 nodes of life. Out of the corner of his eye, he sees the speed needle creeping down again. Add a little more. I'm making the most of it, Dave. The maximum. That's the kind of power that engines only have to withstand for minutes. But this is not a 1-minute flight. It's a struggle. The plane is still descending. It's already a little over 4,000 feet. The ocean is below. You can't see him, of course. The night swallowed everything. But the pilots know. There is no lane, no lights, no landmark from below. Just a flat blackness. Make a mistake, and they will enter it without being able to rise again. And right now, the dispatcher reports, you are 60 miles from Honolulu. 60 miles. It's nothing for a normal airplane. It takes forever for this wounded car. But there is a thin ray of hope. The decline has slowed. The weight is decreasing. There is barely enough thrust to keep the plane in the air. They are still falling, but not at a catastrophic rate. Now there are chances. Now you need to prepare for the next challenge. The most difficult one. Landing. It's still a long way off, but the crew should already be thinking ahead. The problem is that landing without flaps or with damaged flaps means one thing. The plane will be too fast. It will require a huge swath. And even then, with such weight, with such structural fatigue of the case, there is no guarantee that it will withstand contact. But you can check the state of the mechanization only in flight, and only carefully. Let's try 1 degree, Cronin says. The co-pilot carefully moves the lever. There is a subtle, almost painful movement of the mechanisms. The flight engineer listens to the vibrations of the hull. The plane is shaking, but you're not spitting out from under the controls. He's holding up. Let's try 5. 5 degrees of flaps is not enough for landing, but enough to understand how the wing will behave. The plane reacts slightly, and at that moment the co-pilot's gaze falls on the flap position indicator. He sees things that no one wanted to see. Stop. We have a split flap. 2 simple phrases that can be the end of the game. Split flap is an asymmetry. The flaps are out on one wing, not on the other one. This means that one wing generates more lift than the other. If you tried to release more flaps, the plane could simply flip over and fall into a tailspin. The crew must make an instant decision. It's not up for discussion. There is no doubt about it. Don't touch it anymore. We leave it as it is. Now the landing will only be partially slowed down. This means that the speed is too high. The distance is longer than it is. The risks are higher than I want to admit. But there is no choice. The dispatcher gives the vectors. The crew adjusts the radio navigation to ILS. Ahead, in the darkness, a faint light of civilization should appear somewhere. Stripes. Cronin looks out the window. Nothing. It's only night. But the course is the right one. The height is critical, but acceptable. The guidance system is working. We're getting to the beginning of the scheme, Slater says. I got it. Now there remains the question that has been scaring the crew all along. Will the chassis be released? Damage to the fuselage could have affected them as well. If the landing gear does not come out, landing is impossible. Or you will have to land on your belly, and in this condition the plane will not withstand the impact. Cronin sighs briefly, as if pausing between 2 decisions, despite the frenzied tension of the moment. Let's try the issue. Are you ready? I'm ready. Come on. And the lever goes down. 1 second, 2, 3. A soft clatter of machinery is heard. The drives are working. Something is moving. And the green lights on the panel come on. The landing gear is fixed. No euphoria. Only a quiet, restrained relief. Now you have to do the impossible. Land the car so that it doesn't collapse when touched, and so that people could get out of it alive. ChatGPT said, "What is happening in the cockpit now is impossible to convey in one word. It's not just tension, it's not just concentration. It's a state in which a person ceases to exist as a person and turns into a pure function. In reaction, the ability to make decisions faster than fear has time to arise. The aircraft is approaching the starting point of the approach." The navigation display shows a straight course line. In reality, there is nothing flat. The 747 continues to struggle. He is being pulled to the right, the body is vibrating, and with his left wing he is almost pulling himself forward. Working with 2 engines, pulling with all his might a heavy machine designed for smooth intercontinental flights, and not for survival after a fuselage rupture. "Keep the speed at 200, Slater says. "I'm trying." Cronin seems to be pushing against the resistance of the aircraft with his hands. This feeling creates tension on the steering wheel. Handling is far from ideal. With only 10 degrees of flaps, a damaged wing, and a huge hole on the side, the car reacts with a delay, with jerks, with a slight hint of withdrawal. In such conditions, landing is not just a procedure. It's an act of balancing on the edge. The lights of Honolulu begin to appear ahead. They seem small, blurred, like a myriad of quiet points of hope. But pilots know that seeing the lane is only half the battle. It is also important to get on it, and to do it with such speed, such mass, and such damage, that an ordinary aircraft would have long ago lost even a theoretical chance to survive. The dispatcher issues the final instructions. United 8111, cleared to land runway 8L. The voice is calm, professional. It's like he doesn't see what the pilots see. That's their job, to sound so as not to increase the chaos. The flight engineer is preparing for the final phase. He checks the hydraulics. It's working. This gives at least some chance of normal braking. But the reverse will only be on the left engine, Thomas reminds. I understand. So the brakes have to hold up. Must. But no one is sure. The plane is heading out. Perhaps the most important course in its history. The speed is 200 knots. The height is about 1,000 feet. Slight turbulence from the thunderstorm lines behind. Hold 190 to touch. No, at least 200. The co-pilot corrects himself, realizing how thin this line is. I got it, the captain replies. The steering wheel is shaking slightly in my hands. The wings mechanics sense every air irregularity. The flaps work asymmetrically. The aircraft is constantly trying to cling to the damaged side. Cronin holds the approach line literally by willpower. Passengers see the lights of the city. Someone is crying. Someone is holding onto the armrests. Those who sit closer to the right side do not look out the windows. There is no window there. There is a gaping hole, from where the cold and the sound of the wind are blowing. 500 feet from the ground, the co-pilot begins to guide the captain aloud. This is called call-outs, control marks, to eliminate any misunderstanding. 200, 190, 5, height 800. I see a streak. I got it. There is silence in the cabin. Only instruments and voices work. The crew's attention is so narrow that they no longer feel like people sitting in chairs. Everything is just a set of parameters, controls, and sensations from the steering wheel. 500 feet. A little high. Keep heading. Keep heading. The plane is shaking more violently. The proximity of the ground increases turbulence. 200 knots. I got it. 100 feet. The metal of the hull emits a low, vibrating sound. The same one when a huge mass is approaching the ground at high speed. 50. I got it. Don't level up early. 30. The speed is still high. There are few flaps. The plane seems to be falling through, but Cronin keeps it on the line. 10. Touch. The wheels meet the lane with a heavy, deep impact. The car lurches slightly to the right, but the crew instantly takes control. The hydraulics are holding up. The chassis can withstand it. Reverse! Only on the second one! The lever goes back. The left engine begins to take the air forward, creating a drag. Speed. 170. 160. 140. 130. The plane is still rolling long and hard along the runway, as if it doesn't want to stop. The pilots apply pressure on the brakes carefully but persistently. You cannot overheat, you cannot allow separation, but you need to stop quickly. 120, 100, 60, 30, and silence. The engines are shutting down. The plane is parked. Cronin exhales. Only now are his hands starting to shake. Only now does the body remember what fatigue is. Evacuation, he says softly, almost in a whisper. And then louder, in a familiar commanding voice, "Evacuation! Evacuation!" The flight attendants open the doors. People are running out onto the strip. Someone falls to their knees. Someone is hugging. Someone just looks at the plane, which has a hole the size of a truck in it, and tries to realize that he survived. 328 passengers jump out in 45 seconds. 9 of them are already gone. They disappeared into the dark sky 17 minutes after takeoff. But hundreds of people are standing on the runway, shaking, crying and looking at the crew, not understanding how these 3 managed to do the impossible. When the last passengers leave the plane, a strange silence reigns on the strip. Only the breathing of people is confused, deep, almost deafening. Only the distant signals of special vehicles running towards the liner. Only the wind that penetrates through the huge gap in the starboard side, as if studying this giant wound. The plane is standing, twisted, wounded, but standing. The crew descends last. It's always like that. Their faces are pale, but their eyes are clear. They did something that probably no one else could have done in that state of the art, at that point in the night, in that place over the ocean. But now that people have been saved, a different story begins. The story of the search for causes. A story in which the truth will have to be fought as hard as the crew fought for the lives of the passengers. Investigation. The first hypotheses. At first, the version seems obvious. The rupture of the fuselage, the scale of the destruction, the memories of Lockerbie. All this leads to the idea of an explosive device. Investigators are conducting an initial examination. No explosive particles, no characteristic traces of a pressure wave, no soot, no charred metal edges. Nothing. No terrorist attack. Then what? The surviving part of the side tells the story differently. The edge of the gap is bent outward. This is a sign that the pressure inside the cabin has pushed the panel out. Consequently, something opened from the inside by itself or broke off under pressure. The investigator's gaze quickly focuses on one structural element, the cargo door, which is located next to the destroyed section. The logical consequence is that if the door was not fully locked, it could succumb to pressure. and what could have led to incorrect locking. The human factor. Ground service error. It's convenient. Simply verifiable. A few weeks later, the National Transportation Safety Board, NTSB, is preparing a preliminary conclusion. The cargo door was probably closed incorrectly and was damaged by airport personnel. For many, it looks plausible, but not for everyone. Lee Campbell's family, those who disagreed with the official version. Lee Campbell is one of the passengers ejected through a fuselage rupture. His parents, Kevin and Susan, arrive at the scene of the investigation. At first, they are silent. They're listening. They read the reports. They're trying to understand. But then there comes a moment when Kevin, a mechanical engineer by training, looks at the photos of the destruction and says quietly, almost intimately, only to his wife, "It doesn't look like a mistake by the movers." "You mean?" "It feels like the door opened by itself, not because it was closed incorrectly, but because the mechanism allowed it to open." From that moment on, the Campbells begin their own investigation. They request documents from Boeing, review previous incidents, study door schematics, thoroughly reading each report. And what they find turns a private tragedy into a global security issue. A problem that Boeing has known about for decades. In the documents that the Campbells managed to obtain, terrible statistics are hidden. Since 1975, airlines around the world have complained to Boeing about the spontaneous opening of cargo doors. Mechanics have found damaged locks. In some aircraft, the door tried to open by itself, right before takeoff. In one case, Pan Am, only 2 hooks held it from opening in the air. And all this is on the Boeing 747. Official reaction? Quiet bulletins about improvements. Recommendations to improve the service. No mass reviews. No replacement of the entire lock system. And the most disturbing thing, traces of short circuits were already found in the electrical lock control system. This meant one thing. If the wiring shorted out, the system might decide that the door needed to be opened. Not completely. Do not open it outwards. Just loosen the lock first. And then, as soon as the pressure inside the cabin increases at a height, the door will burst. That's exactly what the Campbells believe happened on Flight 811. But there is no proof yet. Just a theory. To prove the truth, the most important element is needed: the cargo door itself. It lies at the bottom of the Pacific Ocean, at a depth that is not so easy to reach. But the search operation still begins. The discovery from the bottom of the ocean is a key moment in the whole story. Almost 2 years. It takes so long to prepare and carry out underwater work. And one day, when a metal fragment slowly rises from the darkness of the ocean, water flows down its curved surface, like tears on the face of a deceased witness. This is the cargo door from Flight 811. It is being placed on the stand. They're examining it. And at that moment, it becomes clear. The Campbells were right. Traces of an electrical short circuit are found inside the locking elements. Not an external blow. No mistreatment. It was the short circuit that led to the mechanism starting to open itself. The locks are loose. The pressure inside the aircraft increased as it climbed. The door exploded outward. Behind it is the fuselage panel, seats, and passengers. Now, this is not a theory. That's a fact. Changing the official version. Under the pressure of incontrovertible data, the NTSB changes the final report. The official cause of the disaster is the structural vulnerability of the Boeing 747 cargo door lock system, exacerbated by defective electrical components. And then a series of recommendations. replacing the locking mechanism on all 747s of the first series, redesigning the fuse system, and limiting the old electrical elements of the doors. Hundreds of aircraft are undergoing modification, and from that moment on, there hasn't been a single similar case. And finally, Lee Campbell's verse. When Lee's parents sort through his personal belongings, they find a notebook. Inside is a poem written shortly before the flight. It's called "Was That Me?" And his lines seem to be woven into the fabric of the tragedy, so strangely, so subtly, and so inexplicably. Air rushes past to fill a vacuum progressive holes which must be filled, waves hypnotizing me with green, beckoning fingers. Not a hunch, but it's like a reflection of what's going to happen, and something that can no longer be changed. Sometimes aviation leaves behind more than just reports, technical diagrams, and summaries. Sometimes it leaves its mark deeper, in people, in systems, in the very structure of how the world works. United Airlines Flight 811 was just such an event. In fact, it is a turning point. When the last sound of the engines of the damaged 747 died down on the Honolulu runway, the world did not yet know that this night would be the starting point for a revision of an entire branch of aviation engineering. Everyone was thinking about the rescued, about the dead, about the miracle performed by the crew. But years later, it will become clear the consequences of this flight will spread much wider than the field of view of that lane. Heroes who didn't call themselves heroes. When Captain David Cronin got off the plane, he looked like he had spent not 25 minutes of hell in the cockpit, but 25 years. His hands were shaking, not from fear, but from overwork, from the force he applied to the pedals and the steering wheel, from the decision he made every second without the right to make mistakes. Slater, the first officer, seemed outwardly calm, but his eyes betrayed a tension that could not be relieved in a moment. He kept looking back at the plane, as if checking if they had really made it, whether it really happened. Flight Engineer Thomas was the last to leave the aircraft. He turned around at the ruptured fuselage, realizing what he saw inside would stay with him forever. Passengers approached them. Many were crying, many could not say a word. Someone just nodded, someone hugged. These three people did not call themselves heroes. But that day, they became. Rethinking the Boeing 747 design engineering is a tough field. There is no place for emotions in it. But the history of Flight 811 has shown that sometimes it takes more than formal tests and bulletins to change the system. What was found in the cargo door, a short circuit that allowed the locks to start unlocking in flight, was a symptom of problems that had been known for a long time. But only this tragedy prompted large-scale changes. The spacer rods and locking mechanisms were redesigned. New protection schemes have been introduced against accidental opening commands. Door maintenance standards have been changed. Reinforced locking structures are installed on hundreds of aircraft. And it saved lives, far beyond the history of Flight 811. Every person who flew early 747 models after this disaster was protected by the decisions made thanks to the Campbells, engineers, investigators, and those who were not afraid to ask questions. The power of human perseverance. The Campbell family. Kevin and Susan Campbell were not investigative engineers. They were parents. Parents who lost their son. And that's why they couldn't stop until they found out the truth. Their tenacity has become an example of how a single family, armed with knowledge and pain, can change an entire industry. And although it won't bring them back, their work has saved an unknown number of people. The final lines of the NTSB report became not only a technical recognition of the problem, but also a kind of memorial to all 9 victims. A reminder that no loss is in vain if a lesson is learned from it. The fine line between life and tragedy. Flight 811 has become a unique example of how the combination of crew skill, structural strength, and a number of accidents can separate life and death with millions of invisible threads. If the door had opened a little higher, there would not have been enough time to descend. If engine number 2 on the left wing had also failed, the plane would not have held its course. If the landing gear had not come out, landing would have become impossible. If the captain had tried to release the flaps earlier, the car could have gone into a roll. Every if in this story is a black dot that you can stare at endlessly. But the story is not about how many risks there were. It's about the fact that hundreds of people have survived thanks to several timely decisions. What remains after such nights? In aviation museums, Flight 811 can only be seen in photographs. It was restored, but never returned to commercial operation. It has become a kind of symbol, a reminder that even the largest machines are vulnerable. But that's not the legacy. The legacy lies in people who will no longer raise their eyes to the sky with fear. Passengers who flew on airliners after 1989, whose design was revised. Engineers who now take into account even those scenarios that previously seemed improbable. And in Lee Campbell's words, strange, poetic, almost mystical. They became a quiet echo of what his parents, the crew, the passengers, and everyone who found out about Flight 811 went through. That's how this story ends, and its impact continues. United Airlines Flight 811 is not just an accident. This is the story of a bug that has been fixed, a history of pain that led to improvement, a story of professionalism that has saved hundreds of lives, the story of people who refuse to remain silent, and, as a thread running through the whole tragedy, the story that even on the darkest nights over the ocean, there is always someone who keeps the plane in the air, no matter what.